Very good. As simple as that. It assigns the tasks and it also tracks them or monitors them, like a project manager monitoring the workers. Pratyusha, okay?
Okay.
And okay, bunch of questions, and almost you're hitting a bullseye on almost everything. That's very good. Huh? And allow me to just wrap up here.
Okay.
Okay. Anything special about masters you can say, Pratyusha?
Special about masters,
Mm-hmm.
it has more RAM, more memory compared to the data nodes.
Excellent. Excellent.
It's an expensive machine.
Mm-hmm. Mm-hmm. Very good. And why would you have more memory, Pratyusha?
Because it's a single point of contact, and we have a lot of configurations done on that.
Lot of configuration. Okay, acceptable. In other words, almost every single request passes through the master, and by having more memory, we will get us faster performance. Is another take on that, Pratyusha. Okay.
Okay.
Very good. Excellent, Pratyusha. Keep it up. I will wrap it up there and we'll move on here. Okay? Great. Thank you, Pratyusha. So that is Pratyusha, guys. And let's see. Yeah, I have resumed the share. And let's see, I think we discussed about name node, then we discussed about the data reading integrity. Any idea which was the slide I was, guys? My apologies about that. I remember I covered data node failure. That's data node failure. And client reading data. 102. Oh, excellent. Okay, I'm right there. All right, sounds good. And Irfan, thank you, buddy. So, okay, guys, so let's move from here. Let's move on from here and see what we have. Okay. Okay. Over there. Give me 1 second while I bring up my tool. There you go. Paste that. Discard that. Cool. Okay, guys. So what do we have? Well, we want to read the data. In the earlier sessions, we have discussed how to write the data, how to load the data, guys. Okay, now we're looking at receiving the data, or reading the data is more precisely, guys. Okay, so again, imagine that is your client somewhere in US, UK, and we have an IT team. That's our project manager. Those are all the developers and things like that, guys. Okay, what would a client do? Well, imagine he's first going ahead and contacting the project manager and telling them, hey guys, I assigned a project, I want to know the status. Imagine. Okay, so what does project manager do? He will look at his metadata, which is like the project plan, and he will try to understand which are the developers, what is assigned, what are the tasks, who are the backups, and things like that, guys. Okay, so in other words, if a client wants to read a file, result.txt, that is like a project he wants, status of project he wants to find, he goes to the name node, who is the master, and master is looking at the metadata, and then he's coming back and saying, hey, if you want to read that file is split into block A, B, and C, and here is where the block is distributed, and here is where it is replicated. So the SDR information is what it is passing on, guys. Okay, then what does it do? Here is what it is doing, guys. Okay, what client does is client goes to the first one, block A is replicated in 5 and 6, and it is saved in 1, right? So what client does is it will first read block A. It will try to read block A from data node 1. After it successfully reads, then it goes to block B and tries to read it from 8, which is there. Then only it will go ahead and try to read the C, which is the first one. It will maintain that order, guys. Okay. At the time of reading, it will do it sequentially. At the time of writing, if you remember, it is like the 3 rooms in our house where 3 people are opening their taps and the water is flowing parallelly. So write is parallel and read is sequential, guys. Okay, that's what we should remember. Client receives the data node list for each block from the master. client picks the first data node. So for each one, I've been specific in saying it's reading. Why? It's for optimization. That's the internal optimization, guys. Okay. Only if this data node 1 is available, it will go and read to 5. If that is available, it will go and read it from 6. That is the order it maintains, guys. Okay. Everybody with me on this slide, guys? Are you able to recall the write process also, guys? More importantly, cool. Okay. So data integrity and reading data, let's see. Let's dig a little deep. And what do we do? Well, what we are telling is step 1, client needs to read a file. So what is it doing? Step 2, it's contacting the name node and saying, okay, I need to read the file is what it is requesting. And this is saying, hey, you'll find it on data node 12 block 5. So in other words, he's looking at the metadata and replying back with the response, guys. Okay. Then what is client doing? He's verifying the checksum. What is this checksum? Checksum is a process where when this block is nothing but a file on this local file system, guys. Okay. So what checksum is it's a way to verify if that a block is corrupt or not. Again, that's an internal thing. It will verify. It's nothing but a code that it will be generated, and when it reads it, it will again verify with the code, and if the code matches, that is what is the checksum, guys. Okay. To understand that, I think I have some explanation here. Let's see what this means. Okay, guys. When Hadoop client reads a file, it will get a list of the blocks and locations of the blocks replicas from name node. We discussed that. The blocks will be sorted based on the distance from the client. In other words, that's just kind of an optimization, inbuilt optimization. We say they are sorted and they're more close and things like that, but more of an optimization technique, guys. Okay. The client will attempt to find the closest block replica, again, part of the optimization. If the data node is down or the first replica is corrupt, then the client will get the next replica from a different node, and the client will validate checksums to make sure that the block is valid. Actually, the checksum is nothing but a kind of a code which is saved along with the file. So it will go ahead and verify if the code is matching or not, guys. Okay, a computed checksum is compared against the stored checksum. In other words, a computed checksum, a computed code is verified with the stored code in that data node and verifies if they both match, it's not corrupted. If they don't match, then it is corrupted, guys. Okay. If the client detects a problem with checksum, it will go get the block from the next replica from a different node. There you go. It keeps continuing. That one. That is what that is, guys. Okay. Everybody okay with this one, guys? Don't get too much bogged down onto checksum. It's just a process way of verifying the if the file or the block is corrupt or not, guys. Okay. Everybody okay, guys, with this slide? Cool. Okay. Move on. Okay, now comes secondary name node, slightly involved here, guys. Let's try to understand how that works. Okay, take a look at this one. That's your master. Imagine that you're in an IT company. That's your hardware manager. Who's this guy? Imagine, for sake of simplicity, this guy is called as a backup project manager. What does this guy do? He's not a hot standby. What is a hot standby? In case if this server goes down, immediately this server will start picking up the requests and start serving them. But that is not what it does. That is why it is called it is not a hot standby. Hot standby is something which immediately serves. This is not hot standby. Okay, it connects to name node every 1 hour. It's like saying this secondary project manager, every Friday he comes to the project manager. He will take a backup of his project plan, and he will go ahead, save it, and keep a copy of it in his server, guys. Okay, so he's connecting every 1 hour. He's doing housekeeping. What do we mean by housekeeping? What he's doing is he's just doing copy pasting of what? Of the metadata. Okay, and that is what we mean by housekeeping. He doesn't do anything complex. It's just as simple as he just copy pasting a couple of files from another server. That's why it's referred as housekeeping, guys. Okay, saved metadata can rebuild a failed name node. In other words, okay. So let's come here. This is, let's say, a couple of files. There is something called edits log. There is something called fsimage. What name node does, secondary name node does is it copies these 2 files here. Cool. Copy, step 1. Step 2, it merges them. When it merges them, it becomes 1 file. And let's say, we'll change that to, let's say, green. So, and then once it is saved, it merges them, it goes back and saves it pastes it there. It copies it here and pastes it there. So what does it have? It has a backup here. Oops. there is one backup which is sitting here. There's also the backup which is there, guys. Okay, at any point of time, if the name node goes down, we can go ahead and restart the name node. Okay, so in other words, you restart the name node. Cool. Let's say that we restarted it. Then what do? We get the latest backup from here. We paste it there. Who? The admins will do that. And then what will happen when they start name node process? Name node will actually read this one and load its metadata and load this into the RAM and maintain it. That is how you can visualize it, or that is how you can think of it, guys. But let's dig a little bit deep into it and let's try to understand what is happening here. Okay, so here is what is going on, guys. There's the primary name node and there is a secondary name node. Let's come here, choose that one. Cool. And in the primary name node, there are a couple of files. One is called edits log file and another one is called fsimage. Let's try to understand what these things are. Okay, to understand that, let's say at 7 a.m. Let's say we let's also go ahead and this is a brand new cluster. For sake of simplicity, let us say this is the RAM. Let's go ahead and put the RAM here more precisely. Let's say this is the RAM here. Come here. Okay, this is the RAM, guys. Okay, it has heavy RAM. At 7 a.m. nothing was there. For sake of simplicity, imagine this is a brand new cluster. Now what is happening? Here's what is happening. File 1. We're loading file 1, which is, if you remember, we are going ahead and using a command called Hadoop fsput. So come here. We're loading file 1. When we load file 1, guys, what happens is, imagine it first makes a note of, in the edits file, at 7 a.m. it makes a note of F1 here. Then imagine it's making note of F1 here. Okay, now what happens is at 8 a.m. Come here. At 8 a.m. what happens is your secondary name node connects to primary name node. Every 1 hour it is connecting. When it connects, what it does is, this is called an edits file. It's like a log file. And inside that you have F1. What the first step it does is, it creates a new file called edits.new. Okay, so that at 8 a.m. when the secondary name node connects, if anybody goes ahead and tries to load that file, it will no longer use edits, but it will use edits.new. Okay, step 1, it creates a new file called edits.new as a kind of a backup. And then step 2, it is copying this edits file, and this fsimage. Notice, in edits and fsimage, we just have F1. So what happens is, imagine at 8 a.m., F1 is copied here. F1 is copied, step 1. Then these two files are merged. When you merge those two files, your F1 gets copied and F1 gets into that file. That merged file is called a checkpoint file. Okay, that is called a checkpoint file. Then this is copied here, this is pasted here. Then it is renamed as fsimage. So now what happens at 8 a.m., imagine your F1 gets into there, into fsimage. Okay, so now come here. There is fsimage with F1. Now what you do? Well, you go ahead and in this edits.new, this is renamed to F1. Edits.new is renamed to edits, guys. Okay, so when you rename it to edits, it becomes a new file. So what will happen? That will get deleted. So it's like a brand new file is now what is happening, guys. Okay, let me a little bit of cleaning. Okay, so now edits is back, and what do you have? Here's what we have. In our fsimage, we have F1. In the RAM, it continues to have F1, and in the checkpoint file, in the secondary name node, we have F1. And here also we'll have F1. This fsimage is now FS. This checkpoint is now fsimage, which is same as that, which is that one, guys. Okay, everybody with me so far, guys? Gentlemen, ladies, are you with me? Okay. Okay, so to understand that, now let's take another scenario. Let us say, let's start with 9 a.m. That happened between 7. We'll repeat the same process with 9 a.m. 9 a.m., let's say for sake of simplicity, we're going ahead and plugging in F2. So what will happen? Step 1, imagine F2 is getting written here. Or more precisely, let me say 9 instead of 9. Let me take a simple scenario. Let's say at 8:30. F2 first will get written here, then it will come here and come here. F2 is written to the RAM. Okay, and then what will happen? That's all. F2 is there in the edits log file and it's there in the RAM. And then now come here at 9 a.m. Come here at 9 a.m. Every 1 hour second Indian node connects. So it connects. So what will happen? Your first edits is renamed as or a new file called edits.new is created. Step 1. Okay, step 2, F2, this edits log and FS image are copied here. So what happens is now this will become, this is edits has F2 and FS image has, come on, what's that? Oops. FS image gets a fun from there. Okay, that is step 2. Step 3, it's merged. So what will happen? Well, your merged file will now have F1 and F2. Then what is happening? This is getting copied here. So your F1 and F2 are copied here. F1 and F2 are getting copied here. And now this is renamed to FS image. So what will happen? Your FS image, come here. F2 is getting updated there. Then what will happen? Your edits.new is renamed to FS image. So what will happen? This will become a brand new file again. Then this is happening at 9 a.m. It should take about few seconds to few minutes to complete this process is what happens, guys. Okay, so now at 9 a.m., let's see what is happening. FS image has F1 and F2. In the RAM, we have F1 and F2. And in the backup also, here we have F1 and F2, all well. But let's say at 9:30, let's take another scenario. At 9:30, let's say we plugged in another file called F3. What will happen? Well, step 1, go ahead and select this, plug in F3 here. And what do you have? Well, we'll plug in F3 here, come here, F1, F2, F3. We plugged in F3. Then what happened? Well, that is what is there. And now let's take up the scenario. Probably Advait is also trying to ask the same thing at 9:45. What happened? For some reason, generally enterprise class servers don't go down, but this whole thing goes down. This server goes down. Okay. Now, what do we have? Well, notice this will get cleared. This will get cleared when we restart it. The RAM is cleared. Everything else will be there, and F3 is F3 will be cleared. F1 and F2 is what we'll have. The process is copy this checkpoint file from here into this one and paste it here. Paste it as what? As FS image. In other words, what do we have? We have F1 and F2. But so F1 and F2 will be copied here. When we restart the name node, it will go ahead and load that into the RAM. So what will happen? Your RAM will now have F1 and F2. But what happened at 9:30? We have loaded F3, which was there in the RAM, which was there in the edits, but did not load it. What happened? Well, in other words, that metadata is lost. The file may continue to exist on the data nodes, their bytes, blocks, and things like that. But what is happening is the file, the metadata is not there in the RAM. That is what happens, guys. Okay. So what do we do? Well, a developer or an admin may have loaded a file, and somebody reports saying that, hey, you said that this file is there, but I can't see it on HDFS. And what will they do? Well, they'll go ahead and reload it is one option. Okay. Is one option, guys. Okay. But what is that? That's a slight, issue, or that is one issue. From edit to, that should be real, I mean, a split of seconds, Srijan, to be more precise, that edit to edits.new is really a split of second. And so we aren't having complete backup. Okay, so that is a slight issue, Advait. So really what will happen, that is an issue, that is true, that is one of the, disadvantages, or not necessarily like a, bad disadvantage, but that's acceptable. Acceptable in sense, they should go ahead and be able to reload the data back into it is what it is. And what else we have, guys? Okay, and that is generally treated as a issue with the secondary name node, guys. Okay, so that's why we need to, and this is in Yarn, which is in Hadoop 2.0, they came up with an active name node and a standby name node where this kind of issues will not occur. How? We will see that later. But everybody okay with this slide, guys? Checkpointing and name node both are located at the same location. You have a backup of your checkpointing here, and here it is more precisely your FS image. Although you will still have the checkpoint file, but we will never really refer to this checkpoint file. We'll mostly get this checkpoint file and we'll make a backup. We'll see that complete backup and things like that in 2.0 they've been addressed, guys. It is not that it was not addressed, but mostly in Hadoop 1.0 the focus was on solving the problem of big data than providing a hot backup. So that was why it was put as a second priority. Will not be referred while restarting. Will checkpointing be referred? From what I recall, when you restart a name node, it will take FS image, it will take edits file, it will merge them, and it will load up the RAM. Will it go to the checkpoint file? I do not think so, Srijan. I may have to double check that, buddy. Okay, but I'm for some reason I'm very confident it merges these two files and it loads that up into the RAM. Let me know if that makes sense. Cool. Let's see. Let's dig a little deep, guys. It won't refer. True. That's what I'm also saying. Checkpointing. It merges, as I said, FS image and edits log. But let's see what we have here. Okay. So the name node performs this task. FS image performs the task by maintaining two files. This is nothing but the metadata, which is a hard copy. The soft copy is in the brain, in the memory, in the RAM. Okay. This contains the entire file system namespace, which is metadata, which is which blocks, what are their file properties and things like that. Edits, we generally call it as a transaction log or edits log that persistently records every change. So any changes which are happening are not being written to FS image. They're being written to edits log. Again, why? Well, that's an optimization. If we directly write it to there, we'll get into threading issues and things like that at the time secondary name node copies or tries to access the file, guys. So that's why they maintain a separate edits log file. So when the name node starts up, it enters safe mode or a read-only mode. What is the read-only mode? Well, it is when it is starting up, it will try to merge these two files and it will try to load up the RAM. At that time, it will not allow any changes to happen. So it says if somebody is trying to load a file or delete a file, it says no, not now. I am in a read-only mode is what it says, guys. Okay, it loads the two files, applies all the transactions, which means it's merging them and loading it into in memory, and creates a representation of new file and flushes out this new version, guys. Okay, and let's go one more step deep. See what, for example, initially we will have FS image 0 and edit 0. When merging occurs, the transactions in edit 0 are merged with FS 0 and a new FS image 1 is created. In addition, a new empty edits progress is created. Okay, this process is called a checkpoint. Once the name node has successfully checkpointed, it will leave the read-only mode and enables the writes. So once that merging is done, it will leave the checkpoint. But now let's come here and have actually a quick look at these things, guys. Okay, go here. Oops. Second, guys. Okay, so let's go here. And so this is where our blocks were getting saved. Let's right click this one, say open terminal. We can open another terminal like that. Let's say zoom in, So zoom in. And let's come here. Let's go to cd slash user slash lab slash and if you remember, ls will give us a list of files. We need to go into etc. This is where the configuration files will be there. Then we go into HAD op, and then we are looking for a file called HDFS site. These are things that we'll probably, the rest of the concepts will cover today. Copy this. Let's clear this one. Say cat display the file. And now notice for name node. For the last session we looked at data nodes. This is a property, and this is where all the blocks were getting saved internally, guys. Okay, but this is the place where it stores the name node. So let's copy this one. Control Shift C. Let's come here. Let's clear this one. Say cd Control Shift V plus enter ls, and then go into cd current. Okay, see this edits. There is something called edits in progress, and these are all the previous edits log files. And we should see an FS image 32 and things like that. ls ltr. So this is the latest edits log, and this is the latest FS image, and this is MD5 file, which is used for making sure it is not corrupt, the checksum and things like that, guys. Okay, but don't worry about MD5. More precisely, that's your FS image, that's your edits log file. Okay, and we are located in this directory. How did we come here? Well, we configure it. An administrator will configure these things. They will have their standard practices where they would like to store these things. They can be on external servers or on other locations. Also, is what it is, guys. Okay, everybody with me, guys? Cool. Okay, so that is that one. Come here. Come back here. So now let's move on to what is called rack awareness, guys. Okay, come here, snap it. Okay, we have already briefly discussed about this, guys. Okay, what is the objective of rack awareness? Never lose all the data if the rack fails. What does that mean? If a rack fails, we don't have to have all the servers failing. We can just have a switch failing. If a switch fails, all these servers or nodes are connected via the switch, so the entire rack is down. So what happens is, if we store all the 3 replicas here, all the 3 copies of a block here, all the blocks are getting unavailable, guys. Okay, so what do? We always store 1 block in one rack and a couple of backups on another rack. As simple as that, guys. Okay, so that is what we mean by never lose all the data. Keep bulky flows in rack when possible. And Hadoop is optimized when it needs to transfer the data from one server to another server. It knows that if it transfers if it transfers the same block of data across multiple racks, it will take jump 1, jump 2, jump 3, jump 4. That's about 4 jumps. Okay, so what that means is, more jumps is more distance is more time is more network bandwidth, more network bandwidth is less performant. Okay, or it takes a hit on the performance is another way to look at it. Or more precisely, if it needs to move 1 block from one rack to another rack, if there is space available, it will try to keep the movement of the data within the same rack. That is what we mean by keep bulky flows in rack when possible. And that is, again, Hadoop is optimized to understand that. How? Well, imagine an administrator will maintain a script or more precisely a file where it says, hey, rack 1 has this IP address 1, 2, 3. 5 has this same. So name node, the master, is constantly loading up, looking at this file to see which are the servers available in which rack and things like that, guys. Okay, assumption that the in-rack bandwidth is higher and lower latency. So if we have to move the data within the same rack, we need less distance, less time. So the the bandwidth will be higher and it will take less delay. Lower latency is lower delay, guys. Okay, am I making sense, guys? Are you able to understand that, guys? Cool. Okay, let's also dig a little deep. Well, there's the block A, B, and C. We say the block A there. The 2 copies are getting replicated there. That's block B. They get replicated there. That's block C. They get replicated there. That's the process of replication, guys. Okay, let's dig a little deep into replication placement. And here's what is happening, guys. The Hadoop client will try to put the first replica on the data node closest to the client. The goal is to get the first replica on the disk fast. So save the first replica as fast as you can. The goal of the second replica is availability. If rack awareness is configured, each data node will have a rack ID associated with it. The second replica will be placed on a different rack in the cluster. The goal of the third replica is to put this block on a separate node, but minimize inter-rack network traffic. So at the time of copying the third, they're going ahead and putting on the second rack itself. So thereby, the movement of the block is within the same rack and not across multiple racks. So the distance, time, everything will be less and faster in performance, guys. Okay. And we can also configure so that we can have store more than 3 replicas. In such case, they're all stored in a random way. If we really want to customize it, it is also possible, but we'll need to write as a different rack awareness script, guys. Okay, generally people don't go that far, would be my take. Everybody okay with this one, guys? With this slide? Gentlemen, ladies, cool. Let's also, okay, so that is replication placement. Let's move on to the next topic, which is unbalanced cluster, guys. Okay, so let's see what we have. Imagine, here's what we have, guys. Okay, Hadoop prefers local processing. What is local processing? Or Hadoop prefers data locality is another way to think of it, guys. Okay, so imagine on day 1, this is day 1, we have rack 1, we have rack 2. There are about 10 servers there, and there are about 10 servers, a total of 20 servers. For sake of simplicity, imagine there's about 20 terabytes of data we stored in these 10 nodes, and there's another 20 terabytes of data we stored in rack 2. On day 1, we didn't have these 2 racks, guys. Okay, we just have a couple of racks, and for a total of 40 terabytes with 20 nodes. So each node, we will assume we have a couple of terabytes of data. Now, if we come here, imagine that's your laptop. Now what are we doing? Let's come here. Let's take this one. We have started writing some Hive and Pig scripts and things like that. What will happen? Well, here's what is going to happen. Your code, imagine, let's say, is moving to all these servers, and the processing is happening on all the servers. For sake of simplicity, we'll just put a couple of those yellow things. But imagine on all the servers, the processing is happening. Okay, why? Well, that is what is data locality, guys. Okay, so no problem there. Everything all well. Okay, and that is what is local processing, data local processing more precisely. That is what this one is, guys. Okay, now let's say on day 2, we added a bunch of racks, a couple of racks again with about 10 servers there and about 10 servers there, guys. Okay, so let's come here. And now, let's say, again, for sake of simplicity, we'll be running the same script here that we ran yesterday. Okay, so what will happen? Well, your code will move to these 10 nodes. The code will also move to these 10 nodes, and the processing is happening. What is the problem? The problem is the code is never moving to this rack, to this rack. In other words, all the processing is happening here and here, but in spite of new racks with multiple nodes available for us to process, the processing is not happening. What is that? That is called underutilization. Okay, guys? And what will happen? Well, when you have 4 teams and you're only doing 2 teams to do all the work, more bandwidth, too much of pressure, too much of stress, and things like that is what it is referred as, and people will slow down. Or in other words, the performance will be low, guys. Okay, so what is that? That is called an unbalanced cluster. Everybody with me so far, guys? And let me see, Srujan has a question here. Rack awareness helps to identify where the data is stored, and that enables HDFS to replicate in other racks. Helps to identify where the data is stored. No. More than saying where the data is stored, it's a way of storing the data is what is rack awareness, Srujan. I don't know if you're able to see what I'm saying. It is not for finding where it is, but it is more of, how you're saving and how we are saving, more than how we are saying saving, why we are saving like that. It's kind of an optimization. So that if a single rack fails, all the data does not become unavailable. That is what is the objective of that Srijan. I don't know if I'm answering your question, but let me know. Okay. So now, while Srijan is getting back, let's come back here. Let's take a look at what is called cluster balancing. Let's come here. Come here. What is happening today on the second day, because the couple of servers are never getting used, what we will do is we will run imagine an admin will go and run a utility or a tool called balancer, guys. When the balancer runs, what does it do? It does not interfere with any of the jobs or MapReduce jobs which are running behind the scenes. What it will do is it will try to transfer the data at the rate of 1 megabyte per second. There was about 2 terabytes on each one. So what is it doing? It is now, imagine, it is transferring the data from here to this server, and things like that. Then what will happen? Well, imagine now, there's your laptop. We are the developers. We're a bunch of developers. Imagine, come here, take that. Oops, we'll go down. Say, we start writing our begin hype codes. And what will happen? Well, now the code not only moves to these servers, it will move to these servers. It will move to these servers. It will also move to these servers. In other words, we are getting a better utilization of all the servers, guys. Okay, is that making sense, guys? You see that, guys? Is that making sense, gentlemen, ladies? Cool. So instead of 2 teams, we're making use of 4 teams. So faster performance, no more underutilization. And how do you run a balancer? Well, if you were to be an admin, you can manually run it like that, but generally they'll use the GUI tools, admin tools and things like that. And they'll have a small button or somewhere on the Cloudera manager or something like that. And they'll just click on that. Internally, that will trigger Hadoop balancer. And there are ways to configure it and things like that, guys. Okay, let's see if I'm going a little deep here, but that is what that is, guys. Okay, and let's see where we are. Okay, so let's get back and take up some Hadoop commands today. Come back here. The password is Hadoop 123, and come back here. Let me pause the screen for 1 quick second, guys. Sorry about that. I'm gonna open something up here. So open that, and okay, let's go to, I think I have it in sent, right? Sent, and you guys are status science. Didn't I send any mails to you folks, guys? Gentlemen, can anyone of you confirm? Didn't I? Okay, so let me do this, guys. Okay, can you quickly plug in your emails, guys? My apologies about that. And I'm hoping you guys might have completed your formalities like paying the fees and things like that. Sorry for asking you, but can you just plug in your email into this one? Thank you, guys. I appreciate that. Please plug in your email, guys, or please enter your email in the chat window, please. Thank you, Srijan. So, Srijan CRM, let's come here, let's copy this. Spaces, Dwight. And Advait and Usha and all others, I'm hoping you have also completed your formalities, guys. If anybody has not completed, please let me know. My apologies to ask you like that. I didn't get a list yet. Copy that. Oops. Okay. Say copy that. And let's say paste. That is ready. Let's copy that. Let's say paste that. Yeah, Gmail is preferred, guys, because I'll be sharing the G drive. Copy that. Let's paste that. And Ravi Kumar. Okay, we'll copy that. And let's paste that, and that will be HDP online, and this is January 8 p.m. Okay, so I have Srujan, Usha, and B.S. Reddy, 3, Irfan, and Ravi Kumar. That's it. Anybody missing here, guys? Let me see. I got a bunch of others here. Okay, Srujan has a couple of them. Okay, couple of others. There's probably us. All right, guys. So what I want to do is I want to copy all these emails. Say, select them to Control A. Let's say Control A, Control C. And now go to Gmail. Let's go Drive. And I need to go into NAIT. Just give me 1 second, guys. Sorry about that. I'm going to complete this one because if you have this one, that will be helpful for you. And there is this classroom online how to patch. Okay, here we go. No, not that one. Classroom. Here is Hadoop. That is Hadoop all. And this is the VM. Okay, I got it. So I'm going to add. So let me go ahead and share this. Let me paste this one. So I have Srujan, Pratyusha, Syed, Ravi, and Bhargavi. Can I create a WhatsApp group for this team? We may discuss technical issues and help each other. Okay. Yeah. No, that's cool, Srujan. Not a problem, buddy. Go ahead. We may. Okay. Let me just complete one step at a time. Okay. I have shared the deck. I've sent this shared, guys. So I'm going to resume this one. So there you go. That is the VM, virtual machine, and that is the deck. So you can go ahead and look at that, guys. Okay. So let me come back here. And now let's get back into action a little bit. Let's get back in here. And let's go to the terminal to avoid any further confusion. Let's minimize this one. If you remember, we go to places, home folders, guys. And that is a home folder. We go into data, data science, go into labs, and we were here. Okay, so it looks like we have, we were here. So now let's go ahead and do a little bit of playing around, guys. Okay, let's clear this one. Few basics to keep in mind. Whatever is here, that is what we are logged in as. We are logged in as training. And what we will do, if you still remember, PWD means this is the current directory we are. Okay, if you just do a CD in Linux, guys, and then you do a PWD, it will bring you back to your training directory. So if you're any other directory and you just do a CD, it will bring you back to your training, home training directory. Again, training is where we are, what we are logged in, guys. Okay, and then okay, now notice this, guys. This is the virtual machine. This is like a box, and what we will do, we'll go ahead and say mkdir, or more precisely rmdir.dir1. I'll first remove this directory. It is not there, so nothing to worry. So let's go ahead and create a directory called dir1. File exists. Okay. So mkdir, let's say dir2. Okay. Now, if I say ls minus ltr, notice, guys, dir2 is the latest one. It's a directory. It starts with D. That means we have created, it's a directory, and we have just created it, guys. Okay. Now, let's go ahead and clear this, and let's come back to our HDFS, which is here. Let's click on this bookmark, then click on browse the file system. Now we are under the root, guys. This is like your My Computer. And now what we are going to do is, notice if you scroll down here, we don't see a DR1 or a DR2. So what we'll do, or before we look at that, let's go into CD dir2 pwd. So we're in this directory. Gentlemen, ladies, everybody with me so far, guys? Are you with me so far? I just used pwd ls and I just created a directory, guys. Okay, so now let's go ahead and say ls. There are no files there. Let's say gedit, for sake of simplicity, mera bharat.txt. We're creating a new file. Say, touch of patriotism, I hope. Mahan. We'll go ahead and save it, Control S, Control W, close it. Now come here, do an ls. There is mera bharat.txt, guys. Okay, so what is this? We have created a file in a local directory in Linux box, guys. Okay, why we have created? Okay, now what we will do is Hadoop fs hyphen mkdir and then d under root / dir2. We'll create a dir2. Let's run it. This is like creating a directory in HDFS, which is your first floor, if you remember, guys. Okay, so let's come here now. That is root. Let's refresh it. There's dir2. Click on that. Nothing is there. Okay, no files are there. So now let's go ahead and load Hadoop fs hyphen put, and we'll say, oops, put mera bharat.txt. Let's say dot. Okay, dot means, oh no, I'll say /dir2. That's where I want to put that. Let's press enter. So what this is going to do is, this is going to copy this file mera bharat that we just created, and it is going to paste it under that directory. Now if we come here, let's do a refresh. There is mera bharat. It's 21 bytes, a small file. Just for sake of simplicity, there's our data. Everybody with me so far, guys? So now what we have done is, what this command is doing is, it is copying file called mera bharat.txt and pasting it under that directory. Cool, guys? Gentlemen, just one more time, could you give me a quick acknowledgement, guys? You understand that? Cool. Now let's come here. That is what RMDIR means. It will remove the directory in HDFS. So if you don't give Hadoop FS and hyphen, that is in the local file system. If you give Hadoop FS, that means we are dealing with HDFS, which is our first floor. And it's putting it in a simple way. So now if we say Hadoop fs hyphen ls /dir2, press enter, and there is your mera bharat.txt, guys. Okay, so that is one way to look at it. Let's go ahead and repeat that. Let's keep it clear. Okay, we'll clear that. Okay, so that is our mera bharat.txt. Let's do it one more time. Okay, now let's come back here and see what is the next step we have, what we are doing here. Okay, to remove it, we can also do that, but more precisely, let me see what else I have. Mera bharat mahan, we are doing that, we are doing a put. No, let's also take a look at opposite. Notice here, Hadoop, now before we do that, let's do an ls. We have mera bharat.txt in local file system, guys. Okay, what we're going to do is, we'll say Hadoop fs hyphen get mera, not that one, but I'm going to say dir2 / mera bharat.txt, and let's say /root. Oh no, I will just say mera bharat2.txt. Okay, let's run it. Let's do ls. There is mera bharat.2.txt. What is get doing? Get is doing the opposite. What is it? It is going to HDFS location, which is your first floor. It is copying that file, mera bharat.txt. It is pasting in your local file system, which is the current in whichever system you're in. This is a way of loading the data and getting the data. When you are loading the data, you're writing the data. That is when your multiple pipes are getting opened in multiple rooms, and the process is kicking in. Reading is when you're doing a get, we are reading the data. Gentlemen, ladies, everybody with me, guys? Okay, now let's go ahead and see what else we have. That is get and cd pwd. Okay, take a look at this one, guys. Another quick thing, if you type in history, it will give you all the list of commands that we've been typing, before in the past. You can also look at history and kind of get a feel of, some of the commands we tested, and these are probably the things that will be coming up later. We'll deal with these things later in more detail, guys. Okay. Is there any command copy from local? Okay, your copy from local is nothing but put. Okay, good question, Bhargavi. Okay, so when we use put, guys, when we say this put, this merabharat.txt is currently, it is copying from the current directory, pasting into HDFS is what I said. But imagine you have a file in Amazon S3. Okay, what you can do, you can use this put and give this location as Amazon S3. When you use, instead of copy put, we can, if you use copy from local, then what copy from local will do is it will expect, actually, let me back up. When we use a put, we can give any location. This can be a local file system. This can be a file on Amazon S3 or another FTP server or another network servers. If you use copy from local instead of put, this location can only be your local file system. Bhargavi, are you getting that? Cool. Okay. Okay, guys. So let's make a little bit progress. So that is that one. And cat, we may have more. And let's also take a look at another few more commands. Let's clear this one. Let's say Hadoop. Before we do that, let's come here. Let's refresh this. We have merabharat.txt. Now we'll say Hadoop fs -move merabharat.txt. Yeah, you can also use Hue. Okay, Hue is more of a GUI based, and but in general we generally go with our terminals, Srijan. So that's why it's better. We're familiar with this one more, and I'm taking that route. And merabharat.txt. Now merabharat 2 or 3.txt, and let's press enter. We'll let that complete. Merabharat, right? Oh, my bad. So I need to give the complete path here. Otherwise, it'll look in a different location. So we need to say /dir2/merabharat.txt. So what it's going to do, okay, now if we come here, let's refresh this one. Fine. Oh, okay, I moved it to a different location. Okay, so what move does is cut paste. Where did it cut? It cut from this dir2 directory. Now I pasted it in user training. There is merabharat3.txt. It got saved in training. Why? Because if I don't give that / here, see this one for merabharat3, I haven't given the /. What it will do, it will see that I'm logged in as training user. And what will it do? Under user directory, it will go to that directory and by default put it there. That is called a reference path, referential path, not a absolute path, guys. Okay. So absolute path is when you start from /. Otherwise, it will by default refer to that one, guys. Okay, gentlemen, ladies, is that making sense, guys? Okay, so move is cut paste in case you're asking that, Irfan. And it is cutting from the first floor, pasting it in another location in the, you're moving your sofa from one location to another location in your first floor, a friendly way. And again, as I said, if you don't put a / here, oops, there is a slash. If you put a / that is called absolute path. If you don't put a / that is called reference path. Reference path is, it will by default go ahead and put it in your training directory. The directory is also in HDFS or no. This When we are saying Hadoop FS, we are dealing with HDFS. We are dealing with HDFS Bhargavi. If you don't use that FS, then you're dealing in your ground floor. If you're dealing with HDFS, then all our things are going on in your first floor. Okay, Bhargavi? Cool. Okay, now let's take a look at this one, guys. Okay, CP. Come here. Let's clear this one. We'll say Hadoop FS -CP, and let's come here. Mera Bharat 3. Mera Bharat 3.txt. We'll say Mera Bharat 4.txt. And before that, let's come here. Let's go to training. Mera Bharat 3 is there. Let's run it. Okay, it's done. Let's come here. Let's refresh it. There is Mera Bharat 4. What is CP? CP is copying. Copying where? Copying from first floor, pasting it as pasting in the first floor only. Gentlemen, ladies, everybody okay with this, guys? Cool. So that is CP. And where, when I say verify D1, DR1, go to Firefox and verify. That's what we are doing. And we can also type in like this, Hadoop FS-ls. There is your Mera Bharat 4.txt. In terminal, you can verify, or you can also use, I think Srijan, I understand now, what you meant by hue is, instead of looking here, you can look at hue is, I think, probably what you're referring. Now I see what you mean, guys. Okay, generally we directly access our stuff. Okay, sorry about the pause, guys. And that is one. Let's come back here. Let's see what else we have. Okay, head -5. Let's see what we got here. Head -5. There's a file called readme.txt. So if you say head, it will show you. Doesn't have it, huh? Oh, 2.2.2, okay. Readme. Those are the top 5 lines. Head means it shows the top 5 lines. Similarly, tail will show you the last 5 lines. Everybody okay with head and tail, guys? Cool. Gentlemen, ladies, cool. Okay, let's see what else we have. Hadoop FS help. If you say Hadoop FS help, FS is a module, they say. Under that one, under FS, there are different commands and options. So we are looking at some of them. Most common is, not all of them need to be done by us. Admins use most of them, but they are ls, put, get, make dir, and get, copy, move. These are some of the things that developers also. There is your copy from local, copy to local. If you say copy from local, copy to local, that means you can only refer to local file system. You cannot get a file on Amazon S3 or another network server. That is what we have to keep in mind, guys. Okay, and that is help. And let's come here. Come here. So there is Hadoop FS RM. RM means remove a file. So delete a test file. Okay, and RM-R DR1 means that will recursively delete a directory. If the directory has any other files and folders also, it will delete. Okay, test file. So let's come here. Cool. So gentlemen, are you okay with RM and RM-R, guys? I may not necessarily run it, but we have seen how that is. Is it okay if I move on to the next one? Cool. So some of slides, let me discuss like that. This is also, oops, let's come here. You can go ahead and, try to practice these things also, guys. Okay, RMR, we're saying, hey, delete multiple files and folders and skip trash. Generally, admins configure trash and things like that. So if you use that option, it will not save it to trash. It will directly, it's doing a permanent delete, guys. Okay, everybody okay with these 2 commands, guys? Gentlemen, just one more acknowledgement, please. Are you okay with this? You think you can handle that? If you go back and you practice that? Cool, great. Move ahead. See, remove the directory. We've just done that. or maybe we didn't do that, we discussed it. In Hadoop FS, if you want to remove directory, instead of RMR, we use RMDIR. That is one command, RMDIR, DR3, so that will delete it. We can also use, that option, only deletes not an empty directory. So if we use that option, -- ignore, then if there are any files in your directory, it will not delete it. If there are no files, then it will delete it. Okay, delete multiple empty directories. We can also give dir5, dir6 like that. You can give the full path like that, or a reference path. We can delete multiple directories like that, guys. Okay, then Hadoop FS tail. So let's come here. Cool, and let's clear this one. Let's say Hadoop fs-tail mera bharat.txt. Run it. Okay, Mera Bharat Mahan. So when you say Hadoop FS tail, it is going to the first floor and tailing it. I do not think we have a head in Hadoop FS head, but we do have a tail. It grabs the bottom lines of that text file. Everybody okay with this one, guys? Cool. Okay, Hadoop FSDU, it will give you the disk usage. So let's come here. Say Hadoop fs-du mera bharat3.txt will give you the disk usage, how much space it is taking. So it gives in 21 bytes, right? So what we can do is we can also, that is fsdu, we can say -du -du-h, human readable format. 21 bytes, instead of 21 bytes, it'll probably come back and give us in some megabytes. Or, oh no, it needs to be a slightly larger one. But how about, instead of saying this one, let's say / run it. Okay, now notice this. This is human readable. So every file, it says abc.dat is 55 bytes and /dc input is 51 bytes and so on. But this one is 3.2 megabytes. And there is a folder called images that is approximately 427.5 kilobytes. Take a look at temp 41.3 and /user. /user is a directory which is about 1.2 gigabytes. So du represents disk usage. That's in a human readable format, guys. Okay, gentlemen, is that making sense, guys? Gentlemen and ladies? Cool. Let's come here, see what else we have. To empty the trash. This is like, you're removing your trash and you're emptying your recycle bin. Touch, I do not think you will you may necessarily use these things. So I'm gonna, not run these things, but expunge touch is, it will just create an empty file. As simple as that, guys, okay? It's not overcomplicated. And test is to see if a particular file exists or not. Again, a little bit rare with that we would use something like that, but it will just test and see if a particular file exists or not, guys. Okay, so what we'll do is today we'll stop it here, guys. Could one of you make a quick note of slide 130, guys? Okay, great, thank you, appreciate that, guys. Okay, so let's go ahead and take it from here, and let's take a question from Srijan. Looking at the big data architecture hardware requirement, I wonder, does big data serve enterprise customers only or help small, mid-size, assuming if business has? Yeah, absolutely. 50 to 100 is pretty good, Srijan. I don't know if you think that is a solid, but in other words, a short answer is, you don't need to buy all servers. You can go to Amazon and rent them. If you're 50 to 100 employees, they then do not necessarily have to invest millions of dollars or hundreds of thousands of dollars. They can just rent them at a reasonable price and use and throw them, or in other words, use limited as and when you need. Use Amazon storage is very, very cheap, and just bring up your Hadoop clusters on a thing. Okay, let me go ahead and unmute Srijan here. Okay, you're on air, Srijan. Go ahead, buddy.
Hello, sir.
Hey, go ahead, Srijan. Oops. Okay.
Hello, can you hear me, sir?
Yeah. Go ahead, Srijan.
So the question is like, Amazon Web Services, this is quite cheaper. That's fine. But, if you look into the Hadoop systems like Cloudera, Hortonworks, I'm not really sure of the pricing pointers, but, looking at the system and process, does it really help the small companies to leverage the big data capabilities? That was the question, but I forgot. I lost the English a bit. You mentioned something. Have you ever heard of this thing? This somebody mentioned. I didn't catch that thing.
So I think more precisely, I've been referring to the cloud computing is a cheaper way of doing the big data. If you want to take a kind of a rather inexpensive route, was my one take. And as I said, the storage is very cheap, so you can you can also install Cloudera on Hortonworks on Amazon. It is possible. Now they made it possible. We just need to do a little bit of looking into what is the right way. And instead of going to Cloudera Hortonworks directly, so what Cloudera does is, I think they have a limit of 20 servers or 40 servers where they will, you can install Cloudera and Cloudera Manager and play around with it. And if you need any support, I think up to 20 servers they will not charge you. But if you have something more than 20 servers or 40, they will start charging you for each server. So as a result of that, it becomes expensive. And Hortonworks also may have something similar. I did not exactly look at their licensing requirements, or I didn't really have to. But if that is expensive for us, then we can go to the route of Amazon EMR, where Amazon themselves, just like Cloudera and Hortonworks, Amazon came up with their own, way of packaging Hadoop, and they make it available. You can use Amazon EMR, but and then you can, elastically it will grow and shrink. And that is what Elastic MapReduce is. So as you have more data, it will automatically use more number of servers for processing and things like that. But a little bit of administration and things like that will come into picture with that Srijan.
This Amazon EMR is a Hadoop concept.
True. Same Hadoop. The Amazon itself will install, and they have it packaged and ready for us. So what we can do is we can just, using their Amazon accounts, we can configure how many servers we want, how much time we want, and how much is, and things like that.
AWS, with AWS account. We can.
True.
And one final question before we wrap up for this.
That's cool.
Is this Hadoop projects can be delivered on agile model, or it should be like a standard way of waterfall model?
No.
SDL?
Per se, there's nothing like agile. It's just kind of grows in an ad hoc manner, and you have a process of administration. Or short answer, you can definitely do it in agile, but you need to, you may not get it right the first time itself, and it will take a bunch of iterations. Would be my take on that, Srijan.
Okay, so there is no specific development model for Hadoop, like a standard software development.
True. Per se, we are not saying that as like a methodology. We just say it's an agile methodology, but we are not sticking too hard from a methodology perspective, Srijan.
No, okay. That's thanks for the info.
Great. Thank you, buddy. Appreciate that. Some good questions there. Okay, guys. So that is Srijan. So what we'll do is we'll wrap up here, guys. Tomorrow we'll regroup and take it from here, guys. Everybody okay with that, guys? Okay, great. Thank you, guys. You guys take care. And I've shared the stuff, so go ahead and have a quick look at it, and we'll take it from there. Thank you. Okay, Advait, you didn't get it, huh? Can you? It was coming from another email called SciGraph. So I don't know if you're getting confused, or if you didn't look at it properly. So just take another look. It's not coming from my Yahoo mail, but I actually use another assistance thing. Okay, I will try to. Let me see. Plug in your email one more time, Advait. See if you're there. Advait 1, 2, 3, 4. Oh, it's not easy to find here. Chu, Ravi, Aditya, Arvind. Okay. Strange. Let me see. Go and add one more time. Copy that. Come here. Say share. Plug in your name. Advait. Okay, I've added you now. Let's say send. Okay, shared it, buddy. Cool. Great. Thank you, guys. We'll catch up tomorrow, Advait. Take care. Thanks and bye for now.